It's recording now. Okay. So this is the new packet that everybody needs to come in and get. And what it's going to do is we're going to do linear regression, t-test, and confidence intervals, mostly by hand. I'm actually lying because we are still going to use our calculator, but we're going to do it by hand in the sense that I'm not going to rely on the calculator to give me the t-score. I'm going to look at the calculator, but I'm going to do it myself as well, and also how to do my confidence interval if I don't have an 84 calculator. Okay, so right now everybody's putting those 7 dots in there, and they're not looking at a scatter plot. They're just putting them in list 1, list 2. I think I already have mine in list 5 and 6. So let me go look at mine. So now, Paloma, every time I leave the program, it'll pause. When I come back to this, you're going to have to tell me to record, okay? So when I leave this, okay, recording is back on. Since we last left you, we went back and did our linear regression t-test, where it gave me S, it gave me A. What was A?
-0.6162.
It gave me B, my slope.
1.2661.
61 or 64?
61.
And then a second ago, we went back and did one variable statistics for my list 1 of my standard deviation of x's. What was that one? 60, right? So that's my standard. This is the most important number I need to get, especially you guys that have an 84. Because you guys could not do a confidence interval, could you? Not with a calculator. You needed S of E. Remember the formula we saw on the PowerPoint? You need to have S of E. Now you have everything. So S is the standard deviation of all residuals. The calculator gave it to me in the linear regression t-test. If you want to do the fancy formula, go for it. I'll pass. I'll take the calculator answer that everybody got. S of x came from one variable statistics of list 1, most of you. N is the number of data points, whether I need to use it for here, there's N, or N right here. So let's see. Let's calculate SE together. Here goes. SE. Together. What was S according to the calculator? 2 point what? 3085. Divided by, what was my standard deviation of the x's? 6 what?
Oh,
1.5460?
4.60.
4.5460 times the square root of, what's the formula say? N minus 1? What is N minus 1? 6. I'll show you why it's an N minus 1, not an N minus 2 in a minute, when we look at that stupid formula on your AP exam formula chart, which isn't helpful at all, okay? But anyway, for those that have trouble keying this in, please pick up your calculator and you just type in this, 2.3085 divided by 4.560. Is that what you said? 5460. 5460. And then go divide again by square root of 6. That's all you have to key in from left to right. The S divided by S of x divided by square root of N minus 1. And that answer is, hopefully I'll recognize it from the other class,
0.2073.
0.2017?
7.
7 what? 7.3. I recognize that.
Aren't you supposed to multiply?
No, I did it a different way. Since both of those are in the denominator, I took that thing and I divided by this. Then I took that answer divided by this. So that's what you're doing here. The top divided by the first thing in the bottom divided by the second thing in the bottom. That's kind of a shortcut that we use in UIL so we don't have to do multiplying and dividing because we get confused. But you can do it any way you want, Paloma, because you probably would have gotten it right either way. So there's my standard. This is my standard deviation of the residuals. That's what this is. That's the standard deviation of all residuals of my 7 points. A lot faster than doing it for real, the real residual formulas. All right, now, another formula. Oh, okay. T. Let's go ahead and do the T formula. Where's my T at? Right, I thought I wrote it down somewhere. Right here. Here's my T. Now, we already know the answer. Everybody can do this in a calculator. It was 6 point something, right?
Yeah.
So let's see if my secret way worked. What is B from my calculator that he came up with? There it is. 1.2661 minus big B. What would it be in my null hypothesis? 0. Divided by the SE that you just did, the standard deviation of, where is it at? My SE formula. Yeah, that's it. Standard deviation of all residuals. And what'd you get? We got, somewhere I wrote it here. Oh, is that it? 2.3, no. 0.2073? Okay. 2.0, I lost it already. 2 point what?
2.03. 0.203.
Oh, 0.2073. Not a decimal in front. 0.2073. Type that in then. That's just 1.266. 1 over 0.2073. And what do we get? I'm crossing my fingers.
The same thing.
As what?
6.10.
6.10? 10 what?
7.6.
7.6. And our calculator gave us, what did the calculator report?
6.1074.
Oh, who's more accurate? The calculator or my number here? Because it didn't round. It didn't round. But does it make a difference in your T-score? It's just, usually if you go to the table, you can only use 2 decimals anyway, right? So when you go to your table, you can only get T as 2 decimals. So that's a good number. So that's kind of cool that we were able to do that by hand. And then if you want your p-value, you could also do that using your table. Okay? But why do it? We already did it with a calculator. And we did the less than, greater than. Allah's had a 0.99 for less than. Paloma had a, what was Paloma's p-value for greater than?
Sir, may I go to the restroom? For greater than?
Yeah.
8.52.
I kind of disagree. Keep reading it. Keep reading it to the right. Go ahead and read me everything. 8.50 something. Keep going.
5250 094 E negative 4.
What does e to the negative 4 mean?
It means the how many before. Yes.
It's 8 point something times 10 to the negative 4. So what should it have been? At degrees of freedom was 5. The p-value, the probability that t was greater than 6.1076 was a 0.1234. It was times 10 to the negative what?
4.
1, 2, 3, 4, 8, 5, wasn't it?
Yes.
See, so that makes a big difference because what is that pretty much close to? Very small, right? Matter of fact, sometimes your textbooks will call it this, approximately 0.000. Is that also true?
Yes.
But we like to use 4 decimals. So I would rather you write 0.0009. I'd be more happier with that. But does it make a difference? It's still small, right? Very small. Am I recording?
Yeah.
Yes, it is. I thought, did we do it again? Now, that's good. And there's little notes that I typed in this morning. The good news, we could run a linear regression t-test. We could do S of x by doing a one variable stats. We get S from that. B is also in the the linear regression t-test. B is in the null hypothesis. Usually it's a 0. Putting it all together, we already have our t-score. We just did that right here. Putting it all together, we have our t-score. Now, what else we got to do? Why did I calculate SC by hand? So that you could do a confidence interval equation. Everybody should know what SC is because when you do your confidence interval, after you do your conditions and check everything, you're supposed to say this. It's B plus or minus T star times my standard error. If you don't know what your standard error is, how are you going to show the reader that you can do this by hand? B was my slope. Can someone go back and look at what my slope was? I'm plugging it in. Then we're going to check it with a calculator for those that can. What is B?
1.2661.
Plus or minus T star. T star means what is the number that goes in front of my standard error. In other words, I have 5 degrees of freedom. And what area under the curve do I want? If I'm doing a 95% confidence interval. 95 is in the middle. How much is one tail? 2.5. Add that together. 5. That's 0.975. So I'm going to pause this for a minute. Okay, I'm recording again. We're going to insert a t-table so people who don't have inverse t in their calculator have to find this with the table. So let me insert a blank slide. Oh, what was our calculator answer?
2.5705.
2.5708. What did you get between what?
Wait, 0.5.
0.5.
Or 6.
Maria, what did you get? Between what? 2.2 and 2. Well, yeah, but you got to find the t value. Look straight down on the bottom row then. All the way at the bottom of the page. Maybe it'll tell you. All right, I'm going to have to pause this and run. Either way, it's still close to 0.2570, right? All right, so there's my confidence interval formula. By the way, FYI, this piece is called margin of error. Could somebody please take 1.2661 and add this 2.5705, and somebody else do 1.264 minus the 2.5705, and tell me what my interval is?
For
The left side or right side?
right side.
Right side?
Negative 1.3.
Wait. That's the left side. That's negative 1 point, because you did this minus, right? That's the left side.
And the other one?
But negative 1 what?
3065.
3065. And the other side?
3.7966.
7966. So I am 95% confident that the true slope, remember I got my data? I made it up. The true slope of the line, of God's line for that data, where that data came from, my imagination, is between these two. Guess what? If I was doing a t-value, I would probably have to, let's see, I might be failing to reject H9. I can't remember. Anyway, moving on here. There's what you would do if you guys don't have the confidence, the t interval in your calculator. Everybody still needs to get this stuff written down. The problem is, if you don't have the TI-84, you can't double check those numbers. Let's go to the calculator and see what the answers were. Reporting on, something isn't right here. What didn't we multiply? Oh, you didn't, oh, it was my fault. I didn't write it down. Paloma, you are wonderful. If I've not told you lately, what is the SE? So it wasn't Jasmine's fault. It was my fault because I didn't write it down. What was SE? 2070 what? Okay. All right, I apologize. Could somebody multiply those two numbers together? 0.5328. Okay, so what I need is 1.241.
0.5329.
Okay, if you insist. 29. 1.241 plus or minus 0.5329. Now let's do our new one. Let's see if it matches up the computer. 0.7332.
And then 1.79. I mean 1.7989.
How does that match up what the calculator was just giving? Sounds more familiar. Questions? All right, whoever has to go to the restroom, now's a good time to go.
Sir, may I go to the restroom?
And I'm going to insert my table. It'd have been so much easier if you guys that didn't have inverse T to actually have the table. But it is what it is. That's what Mr. Mugrabi used to say.
No, nothing.
Oh, yes, he did. It is what it is.
Yes. I don't know if that was the right one, though.
Z, Z tables, but I hope it's going to give me the T.
The T table.
All right, well, no, that's just Z. No, I don't want Z. I have more tables. I have all the tables that I can insert.
I know.
Maybe I don't. Maybe I'm lying.
Maybe you are.
Yeah, I am a little liar. I lie all the time.
The T table.
I'm lying. I don't have a T table. Oh, I know where I got the T. I thought I put all the tables there, but
Sir, will it work on Z table?
no.
Wait, what number did you say to get? Oh.
The area or the row?
The area.
Area is 0.975. I think what I did was I found it on the internet and just used it.
It's between 0.20 and 0.50.
All right, so we'll do with that then. Okay. Somebody asked over here. All right, what I want to do is, I want us to go and look at a problem here. Keep scrolling through take your pages, find the problem that's marked, I think this one is it. 2005 AP Statistics Free Response, number 5. Find that page. It's a real AP problem in 2005 that uses all this stuff that I'm teaching you right now. Here, I want you to understand something. They're not going to make you do all those calculations. Most likely, they're going to give you this computer printout. And it's so exciting because all the answers are here. I'm going to show you something. Look at here. Write this out. These two numbers are very important. These coefficients, the one that's marked constant is your y-intercept. The one that's marked speed would be the slope. This one is your slope. If I had to create my equation, y hat would look like this. 63.4, I can't read it now, 57 plus 16.2809 x. Watch this, guys. See the next column? Do you see the SE? Do you see it? This is the standard error for the y-intercepts that I don't care about. This is the standard error of the slopes. Instead of doing that big calculation, it's written right there. And not only that, watch this, guys. You remember my formula for standard error? It was S divided by, no, it was,
Yes, S.
it was S. There's S right here. 3.087 divided by what? Of the x's, which is not here. So let me skip that one. Let's do T. T was equal to SE, no, B divided by SE. B is 16.2806. 16.2806 divided by my SE, which I circled as 0.8192. 0.8192. Somebody do the division. I hope and pray it's 19. Right here. I hope and pray it's that. So, you should all be doing the division. Well, I see no calculators being used over here.
19.88.
Oh, there it is. It is that 19 point. Look at that. But see, it's already done for you. I'm just showing you that the SE is right here. So there it is. And there's the p-value. Look at that. You could easily do your H naught, your HA, do your T, do your P, and make your conclusion. It's all here in the printout. If they asked you, okay, let's do letter A. Using the regression output, write the equation of the line. Well, I just did it. Oh, this problem was that John believes that as he increases his walking speed, that his pulse rate will increase. Duh. He wants to model this, so John records his pulse rate in beats per minute while walking at different speeds in miles per hour, and then a scatter plot and regression output is shown. So here's what I'm going to write. I'm not going to write y hat. Y hat stands for the pulse, doesn't it? I'm going to write pulse hat equals to 63.457 plus or minus 16.2819 times the speed. There's your answer for A. B. Does your estimate for the slope and y-intercept parameters have meaningful interpretations in the context of this question? If so, please provide the interpretations. If not, explain why. Here's my interpretation of slope, guys. You always put a 1 under it. The 1 stands for the x. That's my speed in miles per hour. The top stands for the change of the pulse, which is in beats per minute. So let me see. Here's what I would write. For every 1 mile per hour that I increase my speed, my pulse increases 16.28 beats per minute. Does that interpretation make sense? That if you walk a mile per hour faster, your beats per minute of your pulse could go up 16? You're medical people. If you exercise, does it make sense? It's not like he said, if I walk a mile per hour faster, my pulse goes down. That wouldn't make any sense, would it? Medically? Or what if it said, for every 1 mile per hour I increase my speed, my pulse goes up 200 beats per minute? Would that make sense? You're a runner. If you run 3 more miles per hour, is your pulse rate going to go up 200 times 200 more? No, because you're a conditioned athlete. Your pulse is going to go up a little bit, but not much. You know, you'd be lucky you get your pulse rate up to 120. Probably, that'd be like your fastest. Most likely, when you're at cruising speed, you're not even breathing heavy, you're probably still staying at around 90. Probably. Do you ever look at your watch and see where you're at? Okay. I say watch. You have an Apple Watch? You need one. You're a runner. Does this interpretation make sense? For every 1 mile per hour I increase my speed, my pulse goes up 16.28 BPM. It makes sense. Look that's already 2 questions out of 4. You've already passed the AP question. They've already given you 4 points. 2 points, because you only 4 the whole problem. Look at letter C. John wants to provide a 98% confidence interval. We just did that for the slope parameter in this final report. Compute the margin of error that John would use. Oh, I love this. Assume the conditions for inferencing are met. Guys, we just did one. B plus or minus T star SE. Isn't this your margin of error? His pulse was 16.2819 plus or minus. And let's see, degrees of freedom. How many data points did he have? Count them. 1, 2, 3, 4, 5, 6, 7. What's my degrees of freedom?
6.
It's -2. It's going to be degrees of freedom is 5. And it's 9, he said 98%. So I need to go to my table and look for, what's the tail, the right tail? If you got 98 and 1 and 1, it'd be a 0.99. If you're doing inverse T, it's a 0.99 comma 5. Somebody do that, please. Inverse T, 0.99 comma 5. And for the rest of you, I'm going to pause. Hello? Is T star 3.36 approximately? Nobody keyed in T interval. Inverse T, I mean. 0.99 comma 5. Inverse T, 0.995. Why do I got to keep asking? Oh, yeah, but you're doing it. I'm not yelling at you. It's those that aren't even trying.
I forgot where it is.
Second vars, number 4.
Okay, what was it? 0.99?
Yes, 0.99. That's the 99 plus the 1 left tail. 5. Because it was 7 data points.
3.36.
Beautiful. So there it is. 3.36 times SE. SE is in the problem. Right there. 0.8192. 0.8192. Do I need the whole interval or do I just need the margin of error? He says margin of error. Margin of error is, somebody multiply that out. 3.36 times 0.8192.
Wait.
It's 2 things you're multiplying.
2.23.
2.23. Thank you.
You're welcome.
Look at that was already 3 things out of 4. Look at the 4th one. Based on the computer output, is there evidence of an association between walking speed and pulse rate? Tested at a 10% level of significance. Okay, guys. He says do a test. H naught. B is 0. No association. Blah, 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 blah. HA. B does not equal to 0. That means there is an association. T. I already did the T. It's up here somewhere. What was T? Oh, no, T's already given to us. 19.88. 19.88 degrees of freedom is 5. P-value. P-value is given to me. What's the P-value? I circled it right here. 0. But use 4 decimals. 0.0000. Do I reject the null or do I fail to reject the null? Because the p-value is less than 0.0 or 0.1, I reject H naught. You mean there is a relationship between walking speed and blood pressure and heart rate? Absolutely there is. That's an AP problem. It's doable. It's very doable. Did I turn it back on? Yes, I did.